Hey everyone, welcome back, and today let's solve LeetCode problem 2342 titled Max Sum of a Pair with Equal Sum of Digits. So to kind of break this problem down into a simple, more concise explanation, basically we're given a zero-indexed array of integers, and we need to find the maximum sum of a pair of whose numbers or digits actually sum up to the same value. And if we don't have a pair that exists like that, we simply return -1. So let's go ahead and look at the examples here. For the initial example, we're given an input array nums to be 18, 43, 36, 13, and 7, and in this case our output is 54. Now the key thing here is that we're looking for pairs that have the same sum for their digits, and we have to maximize the value of the sum of those two elements at those specific indices. Now in this case, that maximized optimized sum is 54, right? And the pairs that would satisfy this would be 02 and 14, where 02 and 14 are indices, and in this case 02, or nums at index 0, index 2, is the most optimal solution because 8 plus 36, their digits are both equal to 9, they're equal, and 18 plus 36 equals 54 is the most optimal sum for all pairs of elements that have this kind of solution or this property. Okay, so now let's go ahead and look at example 2. We have 10, 12, 19, and 14, and our output is -1 because there's not a single pair in this input array of elements that actually do have the same exact sum in terms of the sum of their digits. And so we simply just return -1. So for the constraints here, we see that the length of our input array nums is not going to exceed 10 to the 5th power, and any value at input array nums is not going to be larger than 10 to the 9th power, kind of indicating that we can't have like a big O of n squared or, n log n solution or anything like that. So with the problem statement out of the way, I will give you guys a few seconds to just go over this problem in your head and think of a valid solution, and then I'll show you guys how I would optimally solve this problem in a few seconds. Okay, so what is a very kind of naive way to solve this problem? Or a very naive way to solve this problem is just have nested loops, one outer and one inner. Just go through every single pair and maximize their sum accordingly for all the pairs that have an equal digit sum, right? That's a very naive solution. It's not efficient because, of course, that would be a big O of n squared solution, and that would actually give us a time limit exceeded. And so we have to kind of think of a more better and more efficient way to solve this problem. And that kind of leads us to our first observation, and that is basically numbers with the same digit sum, they can potentially form pairs that satisfy this condition based on if they are maximized and if they do have the same exact digit sum value, right? And so that kind of tells us that instead of checking every single possible pair in n squared naive solution type, basically we can use something called a hash map or a dictionary in Python. Basically, we're going to store the numbers grouped together with the key value pair, or with them being mapped to their digit sum. So all the values are going to be mapped to their digit sum, right? Because at the end of the day, that's what we're trying to maximize, and looking numbers that have that property. So kind of how the rundown of our solution is actually going to work. Basically, we simply initialize a dictionary. Its purpose is literally just to map every single unique digit sum to the largest number that we've actually encountered with that digit sum. And then we're actually going to iterate through the array and simply in each iteration calculate the digit sum of each number. We can use the helper function to do that or something like that. And if we've actually already seen another number with that same digit sum, we have to then calculate their sum and then update the maximum sum if it's greater than the previous maximum. Because of course, we want two elements at a time to maximize their values based on if they have the same exact digit sum, right? And effectively, once we actually do that for every iteration of the for loop after processing all the elements, we simply return that maximum sum for whatever value it is. So let's go ahead and get into the code here. So what I'm first actually going to do is, like I talked about before, initialize my hash map or my dictionary. I'm going to actually call it digit sum map. I think that's a good name for it. And it's going to be initialized to an empty hash map. But in fact, I'm actually going to do something a little bit better. It's a little bit more Pythonic. I'm going to use a default dict. It's also known as a default dictionary, and its key value pair or data type is going to be of type int, right? And again, the whole purpose or use case of this data structure, of this hash map specifically, it's basically going to be storing the largest number that we found so far in each iteration for every single digit sum, okay? Now let's actually initialize our maximum sum, what we're eventually going to be returning as our answer, and it's actually going to be initialized to -1, right? Basically, that's in the case if we don't actually find any valid pairs. If we never actually update it, we simply return -1, and the whole purpose of this is basically actually to kind of get the maximum sum for whatever it is and effectively return it. And we would, of course, return -1 if we didn't find any pairs, if we didn't find any valid pairs, that is. So I'm actually going to quickly get a helper function, and I'm just going to call it getDigitSum. And like I was talking about before quite briefly, it's going to take in one parameter of a current number or a current element. And it's literally just going to return this digit sum, whatever that is. And something a little bit Pythonic here. In fact, actually, I'll pass in n. I think that's a little bit easier. So it'll take in a parameter n, and it's literally just going to return the sum of its digits. And a way to do that in Python is simply just return using the sum method here in Python. And the way I can do this is take the integer of every single digit for every single digit in the n, or the n element. But a key thing here is to note that we have to actually iterate through the string of the n to actually convert it to an integer and incrementally update the sum. So I'm going to use the string converter or built-in keyword here. And I think this is correctly formatted syntax-wise. I hope it is. If we do get a syntax error, sorry about that. I will get back to that if the editor throws one. Okay, and effectively this is just what we're going to be calling on each element if it actually does have a bigger maximum sum than what we found so far. It literally just computes the sum of all the digits of a given number. In this case, that's n as our parameter of this function. It's going to first convert that into a string using the string method, and then iterate over each character, and then for every single digit, it's going to convert it into an integer, and then sum it all up, right? And I think this is something called list comprehension or dictionary comprehension. In this case, just think of it as a one-liner for loop, okay? Now let's actually initialize now let's actually iterate through the input array and maximize that sum accordingly using that hash map and these maximum sum integers. So, and the way I can do that in Python is simply for every single value or number. So I'll just say num in the input array num, iterating through each element. Basically, we'll get the current digit sum of this element, and it's just going to be the helper function at that number. And the way I can do that in Python is simply get digit sum, call the function, and in this case, pass in the current element num, or the current value or integer num, right? We're just computing a digit sum using that helper function's call, okay? Now, what if we've already seen this digit sum in our hash map? Meaning, what if we've already encountered a different element that already has this digit sum? And a way to check that in Python in the context of this problem is, what if this digit sum has already been initialized and seen before in our hash map? And keep in mind, we called it digit sum map. That basically tells us that, of course, we have actually initialized or checked this digit sum before. We've encountered it before. And if that is the case, then we want to maximize using this current element for the maximum sum, or if the current maximum is already big enough for this current element. So I'll get the maximum sum and update it to be the maximum of course, itself, because we don't want to make it smaller. And the second parameter that I'm going to get is going to be digit sum at the current digit sum of the current element plus the number itself. Plus the number itself, because keep in mind, digit sum, I should have a map here. So keep in mind, digit sum map at digit sum simply just keeps track of the highest value in our input array nums that actually has this specific digit sum as our key. That's a very key thing to note. We're not actually adding this number's digit sum to the number itself. We're adding the highest number value that has a digit sum with the current number if they do actually have equal digit sums. And of course, they're guaranteed to if we actually are checking that it is already in the digit sum map. Right? This is the main thing. If we've already seen this digit sum before, we're calculating the sum of the current number and the stored maximum number so far for this exact same digit sum from our hash map. And if the sum is greater than max sum, then we'll update it. If it's not, we simply keep it as the same using that max built-in method. And then we have to actually update our digit sum with the maximum keyword again. And that's basically going to be very straightforward here. It's going to be, the key should be digit sum. Sorry about that, guys. What if the current element number, what if it's greater than the previous highest element that had this digit sum? If that's the case, we have to update it accordingly. So it's going to be the maximum of the current value, digit sum map at digit, or the current value itself, right? The current number as such, num, right? We're actually updating the dictionary to be the largest number found so far for this current digit sum. Either the previous largest element that has this current sum digit sum is greater, or the current element itself has a higher value that actually does have an equal digit sum. And effectively, once we actually process it for each element, we simply return whatever our maximum sum is. And if I were to submit this, unless they made any syntax errors, either should be accepted and there should be a valid solution. And as you can see, this really is just about as efficient as you can get it to be. Right? So now let's actually go ahead and talk about how this code actually works as a whole. Again, to kind of reiterate what this does, it's basically going to return the largest sum of a valid pair if we actually found any, but if we didn't, we simply return -1, or because of course that's how it was initialized. Now, for the actual kind of high level run of how our solution actually works, of course, we actually just iterate through the input array and process each element once and compute their digit sum in each iteration. And we're actually using the dictionary to keep track of the largest number seen so far with each digit sum or for each digit sum. And if we actually do find a number in the current iteration with the same digit sum as one that we've seen before as a previously initialized key, then we have to actually check if their sum is the maximum so far and update this largest value that has that digit sum accordingly, right? And at the end, we simply return the maximum sum that we found for across all the valid pairs, or we simply just return -1 if we didn't find any valid pairs and update our digit sum at all. So for the runtime complexity, it's actually going to be big O of nk, because of course, to actually compute the digit sum for each number, that would be big O of k time. K would be the number of digits in the current number, and iterating through the list or input array would also be big O of n. And since we actually process each number once, and all the dictionary operations are technically constant or big O of 1, the overall time complexity would be big O of n times k, or nk. And the memory or space complexity is really just linear. It's really just big O of n in the worst case. Since worst case, at most, we can store n entries in our dictionary, where again, n is basically the length of our input array nums. And yeah, that's about it. So if you guys enjoyed this solution and learned something new, please consider liking this video and subscribing to my channel. And without further ado, I'll see you guys in the next video. Bye-bye.